Buenas tardes a todos en otra sesión híbrida, pero esta vez lo importante es que tenemos una sesión presencial de Madrid Jack. Volvemos después del intento que hicimos en diciembre y que fue premonitorio de la enésima ola, pero esta vez ya es la definitiva. De hecho, volvemos con los meetups presenciales, volvemos a vernos las caras, volvemos a luego a tener la posibilidad de conversar y ya tenemos preparados algunos meetups más a final de junio y probablemente tengamos alguno entre medias también. Entonces, hoy esta charla he empezado en castellano, pero la vamos a dar en inglés porque entre la audiencia tenemos alguna gente que no es española. Entonces, voy a cambiar, la charla no la va a dar en inglés y voy a cambiar yo a inglés para acabar con el resto de la presentación. So, welcome everybody. For those listening at home and for those of you listening here, this is welcome to a new meetup of the Java user group. We were really looking forward to have the opportunity to go back to in-person meetups again, so that we can have the opportunity to have some conversations ongoing after the talk. In this case, we are lucky to have two former usual suspects of the Java user group. One of them has already delivered some talks in the past in the Java user group. Maybe you could remember them from, how was it called? Mutation testing. Who was the Watchman? It was called, about mutation testing. But today they are here to speak us and to guide us on walk through all the features of Kafka. I think that they are going to start from the very beginning to give a brief overview of what Kafka is and how it could be used. But we will also have the opportunity to take a look into under the hood and go deep into some of the details of how Kafka works and how we can benefit from it. So without any further ado, I'm going to give the stage to Manuel Falcón and Rafael Vindel, that are going to also introduce themselves and maybe give us a little bit more of context on why they are the right people to speak about Kafka. So welcome.
Okay, so hello everyone, and thank you for coming today. And welcome to the Global Madrid office. And we're going to be talking today, as David said, about Kafka, the Kafka ecosystem. And our talk is Kafka, Let It Flow, and hope you like it, okay? So my name is, as I said, Manuel Falcón. I have been happily working in Globo for the last 6 months and working as a backend engineer, okay? And here's my friend.
Yeah, hi everyone. So I'm Rafa. I'm also working for Globo, like same as Falcón. And well, today we are here to talk about Kafka, as David mentioned. So we are going to see two different parts. The first one is the components. We are going to check the main parts about Kafka, and then we are going to move into the APIs, okay? We have split it into three main parts. The first one is move APIs, that we call like that because we are going to see the producers, consumers, and connect process, and then SQL, okay? And we are going to check also to some examples about them, okay? If you have any doubts, we are not taking the streaming, by the way, but if there is any question or something, we can check at the end or during the presentation, okay? So components. We start with the event. An event is something basically that happened in the system, okay? So that happen is going to be serialized and written into Kafka. Inside an event, we have 4 different fields. We have the value, that is the content that we actually want to send. We have also the key, that is optional but plays an important role when distributing the messages, as we will see later. And it's also really helpful to correlate events, okay? We have the headers that are useful, are also optional, but really useful for store application metadata, like, for example, distributed tracing. And also the timestamp, that, as we will see later on, is really helpful to take benefit of some time-dependent features. So events need to live somewhere, so they are categorized into topic. Topic basically follows a commit log structure in which the events are written into an append-only fashion, and that's why Kafka is so fast, okay? So once an event is written into the topic, it will get assigned an offset that is an integer value that always increases. Okay, so we can see that 1, 2, 3, 4, 5, and once an event is stored, it's immutable. Okay, we can't change it. So if we just see a topic as a simple log, it doesn't scale. So that's why inside topics we have partitions in a configurable number of them. Okay. So as we can see here, based on the colors, we have events with the same key, and events with the same key by default, we can configure it later. It will go to the same partition, okay? So we can guarantee the order inside the partition, but we can't guarantee the order on the whole topic, okay? And this combination between topic and partition is what we are going to call a stream of information. That is what we are going to talk during the whole presentation. And now we are going to see for how long we can store these events.
Okay, so now we're going to be talking about retention. So how long do you want to keep your messages on the topic? You want to keep them for a week, or you want to keep them forever in an historical way? Okay. For that, we have a property which is called the cleanup policy. By default is delete, which means that the events are going to be deleted. You have two options for configuring it. You have by time, which is by default 7 days, or you have by size, which by default there is no limit for that, okay? The other interesting part is the cleanup policy compat, which means that we're gonna keep the events, but we're only gonna keep the events. Let's say that you have 10 events for the same key, okay? But we're gonna only retain the latest one. The other ones are gonna be eventually removed, okay? As you can see, in order to be treated with the key is mandatory in this case. And if you want to delete a message, the only thing that you need to do is publish that message with the same key, but with null value. That is going to be called a tombstone, okay? So if in the example that Rafa showed before, we have a compacted topic, eventually with compaction, what we will have is this last snapshot in which you only have the last message seen for a certain key, okay? Jumping now into the takeaways, follow naming conventions. It's important to have your things organized, okay? So you can use things like the domain, your subdomain, what is inside, what kind of information you have in that topic, or even the version, okay? The number of partitions. As we will see later on, number of partitions is the way our system scale, okay? So it's important that the more number of partitions you have, the more scalability options that you have. But there is a trade-off. The more partitions that you have, the more things Kafka needs to keep in sync, okay? The number of partitions can be changed, but we don't recommend it because later on you will see why, okay? What we recommend is just that, okay, you change the number of partitions, instead of that, you create a new topic and move the information there with the new configuration that you want, okay? Next thing, distribute message evenly, okay? Because it could happen sometimes that you could have like some kind of hotspots, which means that, let's say 20% of all your events, for certain key, they all go to the same partition. So you will have one partition so big and the others not. That will have a huge impact on the performance, okay? Last thing that we're gonna be reiterating during the presentation, Kafka is a system which is very configurable, and you have to be aware of what you are configuring. For example, the cleanup policy. If you leave the default, be aware that after 7 days, your messages are gonna be gone, okay? So now let's talk about infrastructure.
Yeah, so basically topics and partitions need to live somewhere, okay? So they live in servers, but in Kafka they are called brokers. Brokers are the physical machines that basically receive the request and write everything into disk. They can handle between thousands of partitions and millions of requests a second. In this example, we have 3 topics, and orders, payment, and logs, and each one has 3 partitions, okay? It's typical, you know, to have a cluster of brokers instead of a single one. So we can see that we have now 3 brokers, and we have seen that the partitions have been distributed across the different members of the cluster, okay? So we can scale horizontally our application by just providing more brokers and then sharing the partitions. Now we have to manage the state, okay? So that's why we have the cluster controller. This special broker is selected randomly, okay, and will manage some administrative operations, such as, for example, the reassign of partitions between the different brokers. Now we can also, you know, like provide redundancy by replicating the partitions across the different brokers. We can specify that by changing the replication factor, in this case of 2, and we have replicated orders and payments, okay, with the different colors, okay, for representing the different partitions. So we have replicated the partitions, and now we have the same partition that we need to define which one is going to handle the reads and writes. So each partition is going to have a leader that will be checking the reads and writes, okay? And the others will need to be in sync with it, okay? Just in case if something happens, okay? If some partition goes down, the other ones that were in sync are going to take the lead, okay?
All right, cool. So now that we have seen how is the shape of an event and where that information lives, we're going to be talking about how we're going to move that information, okay? So we're going to be talking about how to read information and how to write information into Kafka and from Kafka. So the first thing that we're going to be having a look is at the producer. The producer is basically in charge of sending events to the broker, okay? But we don't send events one by one, even though you can configure it. We do it by batches in order to improve the network latency overhead. But as you might guess, it's like there is always a trade-off between latency and throughput, because the bigger the batch size, the less latency, but the less throughput you will have, of course. Another important point is that when you produce a message, the producer knows where it has to write that message to the lead partitions. So it has to have information about in which broker the lead partition lives, okay? That is handled for us in an abstract way, okay? We don't have to care about that because the producer contains like a cache with that metadata information, okay? Now let's jump into the internals. So we have the broker, okay? And with the producer API, giving some configuration like the broker address or the serializers, we're gonna be creating the producer, okay? In order to produce a message, we need to create a producer record, okay? The producer record has some mandatory fields, like the topic, where we're gonna be sending the information, and the value, which is the value that you are sending the event, okay? Optionally, you can specify the partition and the key that are gonna have an important position when you're gonna be sending the information to which partition, as we will see in a second. So we're gonna be calling the method send. Okay, the method send has different behaviors. You can have fire and forget. You can have sync behavior, which means that you're going to be blocking until you get a response from the broker, or you can have async behavior, in which you can register a callback function in order to do whatever you want once you get the response. So the first thing that we need to do is serialize the information. Kafka doesn't understand anything but byte array. So if you go to the server, there is only byte array information. You could have your information in Abro, in protobuf, or in JSON, that's okay. But at the end of the day, what you need to send to Kafka is the byte array. After the serialization, we're gonna be using the partitioner, which is gonna tell us to which partition the information is gonna go. How does this guy work? So first of all, we check the producer record. If you have specified the partition in the producer record, easy, we go to that one. If not, we're gonna be using, and if the key is present, we're gonna be using the key, okay? This is really important because the key, how we're gonna calculate to which partition we go? We do a hash with the number of partitions that we have in the topic, okay? So that, as Rafa mentioned before, is how Kafka guarantees the order at the level of partition, because all the messages with the same key, we're gonna use the same hash function and they go to the same partition. And that's why we specified before that if you change the number of partitions, what happens? You cannot guarantee anymore the order, okay? Anyway, the partitioner can be customized. If neither the partition or neither the key is specified, the producer is gonna do a round robin and that's it, okay? It's important as well to mention that for cases like you have an unbalanced events, like as we saw it before, like let's say you have 20% of your records, all of them has the same key, and one partition is growing a lot. You change the partitioner, you might need to create some kind of customization for that, okay? After we have that ready, we're gonna put the event on a batch. The batch is ordered by topic and by partition, okay? Once the batch is ready to be sent, it's gonna be sent into the broker in an asynchronous way, okay? In another thread, sorry. What could happen now? The happy path. The broker returns us a record metadata with the topic and the partition information and the offset, okay? But of course, there could be errors. There are errors that are not retriable, in which case, for example, we have message too big. For that, we will need to provide some kind of mechanism to deal with that, like a dead letter queue or something like this. Or you could have the retriable errors. An example of them could be leader not available. Okay? In that case, the producer already deals with those retries. And actually, those retries are configurable. Okay? Some takeaways. So please, again, take a look at the configuration by default because it's really important. In this case, you have seen that something as simple as the batch size will have a lot of impact in the throughput versus latency. Not your use case. Are you okay to lose some messages? Because Kafka has what is called the delivery semantics. By default is at least once, but we could have at most once and even exactly one semantics for the delivery. So handle errors. As we have seen, you need to retry, and we have configuration for retry. So that might cause some kind of duplication of messages. So you will have to be aware of that. As you have seen, it's like configuration has a lot of effect on this system. Last but not least, schema. So we are not covering this in the presentation, but we highly recommend to use a schema for your messages because what could happen is that you need to keep compatibility between those messages and evolvability, okay? For that, what we have been using so far is Abro in combination with a schema registry. Now let's have a look at the consumer.
Okay, so well, we have now produced some events, so we have to consume them, okay? And for that, we have, guess what, the consumer side, okay? So in this case, we have a consumer that is going to consume from the logs topic, 3 partitions, so it's going to consume from all the partitions inside the topic, okay? It's going to consume also in batches, and as each event has its own offset, okay? And we need to keep track of which messages have been consumed or not, or processed. Also, the consumer will publish some event to an internal topic called consumer offsets, okay? Sending the offset in which they are processing. As we can see here, this doesn't scale, okay? Because we can have thousands of partitions and just one consumer. So that's why consumers are grouped into consumer groups. We have now 3 consumers for 3 partitions. That relationship between consumer and partition is called ownership. And one consumer can read from multiple partitions, as we saw before, but just one partition can be read by one consumer. Okay, so that means that if we add a 4th consumer, it's going to be idle. It's not going to do anything. Now that we have a group, it's the same thing. We have to manage and control the health of that group. Okay, so one special broker, it could be different than the cluster controller that we have. It's going to be called the group coordinator. It's going to handle and control these consumers. Consumers will be sent periodically a heartbeat to this group coordinator, and in case that some consumer goes down, it fails, it will trigger a rebalance. Okay, a rebalance is basically like a stop of the world in which we need to reassign the partitions to the remaining consumers. So in this case, the second consumer is going to read the 3rd partition. Okay. Now. We can have multiple consumer groups, meaning that we can have different applications consuming from the same topic. So we can have multiple consumer groups for this matter, okay? So we can, and each consumer group will handle the offsets in its way, okay? So we'll handle that. Going to the internals, we have the broker and we have the consumer. We initialize it with the configuration that is the deserializers in this case for the key. In this case, for the key and the value, we have the group ID and the broker list, okay? We also have to subscribe to the topic. And once we do that, it's very common to have a never-ending loop in which we are going to be polling events from the broker. Which information do we need? In the first fetch, we need to know which partitions are reassigned. So we are going to fetch that information also, and we are going to store in the cache, the same as with the producer information. We are going to retrieve a list of records. That's a consumer records class. We can process it, and we need to commit it. Okay, by default, this is enabled. In the poll, also, we handle the heartbeats that from time to time is configurable. We send that we are healthy to the broker. We also handle the rebalance, and we check about the commit. Okay, the commit, as I mentioned, is configurable. By default, is true. And we can configure also the interval in which we are committing the messages. So if we have a low interval, that means that we are going to commit more often. And if we have, for example, like 10 seconds between committing, it could happen that we crash during that time and we reprocess again the messages that we have already processed. Okay, so we have to find the balance in that case, but we can disable it, and in that case we will have the power to decide when we want to commit, and we have two possibilities: commit in a synchronous way or in an asynchronous way. If we commit it in a synchronous way, we are going to be in more control of the commit because we are going to stop till the message is committed. We will have also retries. If something happens, this is going to retry under the hood, but it's worse performant, okay? And we can specify the offset that we want to commit. In fact, we have to specify the partition and the offset, or we can just commit without specifying anything, and we are going to commit the last message read by the pull method, okay? And the same applies with the commit asynchronous way. But this is more performant because it's asynchronous, but it's not going to retry. We have to specify a callback function to handle the error if it's any, okay? So takeaways. Reduce rebalance operations. We have to configure our brokers and also the heartbeat rate to reduce these kind of things because it's going to impact very negatively in how we are going to consume our consumption rate, okay? There is also some configurations for if we have to do a rebalance, how the policy of reassigning the partitions to a different consumers. We can have sticky partitions, or we can have like a round robin, or just like redo everything, okay? Define a good commit strategy, because that will imply the same as, for example, delivery semantics and so. If we can, like lose messages or not process them, or, what are we going to do? Caution with dousing services, because we can consume maybe like really big batches. That means that a lot of events, and if we are, for example, invoking an external service, we can cause a denial of service, so we have to take care about that. So that's why sometimes it's useful also to throttle or to configure these options just to not overload the systems. And guess what? Last but not least, also like appropriate configurations, like you will see during the whole presentation. Okay. So moving to Kafka Connect.
Yeah. So basically, before jumping into the examples and the streaming API, we would like to mention this component from the Kafka ecosystem, which is Kafka Connect, which is the data integration framework built by Confluent. Okay. It's actually deployed in a separate server, so it does not to do with the Kafka server. It's completely separate. It has a rich set of libraries for sources and sync, and what it gives you is like an easy way to put data into Kafka or get data out of Kafka. And as you might guess, it's very useful for legacy systems. Okay. Here we're going to have an example, so you can see this is an S3 sync connector, which is going to be basically in charge of connecting to Kafka and dump that information to S3. As you can see, you have the class, of course, but you have the key things are the name of the topic or the topics, and you have the region and the bucket name where that information is going to end up. Okay? The good thing is that you don't have to program anything. It's something that it's already built. You just connect it, and you want to dump that information. Okay? So now we're going to be jumping into the examples.
Okay, so I don't know how are you with all the, words that we have been mentioning, okay? But let's take a look at some things, and maybe we can like make up our minds, okay? So we are going to use the Confluent platform. So we have like different ways basically to use Kafka. We can have the jar and with different options, but we are going to use this because it's like very user-friendly with this UI, okay? So, well, you will have all the instructions in the README, in the repository, okay? So basically, it's a Docker compose that we will start everything, and we can go to this place, and we have one cluster. We have an overview, we have one broker, the partitions and topics and everything. So if we go inside, we will see the same. And inside brokers, we have, for example, the affect controller. That is the cluster controller that we mentioned when checking about the brokers and cluster things, okay? If we go to topics, we can see all of the topics that we have. We have created these three, okay, just for examples later on. And if we just show the internal topics, we can see here that we have the consumer offsets that we were mentioning, okay? We can go inside any topic. We can see the messages that are being written. In this case, we are not going to see anything because it's serializing to Abro, so we can't see what's written, okay? But we can also define the schema that we want to apply to this, okay, just to map it. If we have any consumer, we can see them here, and we can also, for example, create topics. We have the command line utility, and we can create also from here. So if we want to run some examples, like some producing and some consuming, okay, as we will see, for example, we are going to publish to this topic, okay? Let's customize. This is going to fail, okay? We are going to create by default. If we save and create, we will have there was a problem with the replication factor, okay? This is a cluster with just one broker, so we are specifying a replication factor of 3, and we can't do the replication factor of 3, but we configure this low availability, and we will have just one, okay? So we have created this topic, and we are ready just to see the messages that we are going to produce. All the code is on the repo, okay? This is just like for a showcase. As we were mentioning about configuration properties, can you see like the screen more or less?
Ampliarla un poco.
Okay.
Vale,
I will assume that
yes.
Better like this.
Yeah.
Okay, we have like a really long list of properties. I'm just choose like some of them to comment or highlight. We have the batch size. We have the compression type if we want to compress the messages. We have the AC case. That means that for how many brokers and partitions we have to wait for mark that event as sent, the number of retries if something happened, the retry back off, max in-flight requests per connection. That this is really interesting. This is basically the in-flight request that can happen on the background. So that means that if we are retrying, if we are going to send an event, it fails, we are going to retry it, but at the same time, you know, we can send another event. So as we have more than one in max in-flight request, we can actually send the latest event first than the other one that is retrying, and we can cause that the events are not written in order, you know. So that's why we were mentioning during the whole thing that configuration is really important, depending on the use case, of course, because it will impact the use case and the performance, okay? Basically, this is like how we can play with the producer. We can send a message. Some interesting, for example, functionalities. The linger milliseconds is the time that we have to wait for sending a message. So in order to improve this experience, we are batching them, okay? So if we configure the linger milliseconds to 5,000, in this case 5 seconds, we are going to wait for 5 seconds to send the message. What happens if we just run this program? We are not calling the producer.close, okay? But if we run this, this example, we are not going to publish anything, okay? If we go to this side, we don't have any new message. It's basically because we are not closing the producer and because we are waiting 5 seconds to send the message. So the application exits before that, okay? If we, for example, configure this just for sending a message, and you can see it, the linger milliseconds is 0 and the annulments 1. We have received the offset 0, that is the position that that event has inside the topic, and we can see here the event, okay? We are not sending anything fancy, okay, so don't worry. And for example, just to try with the asynchronous way, okay? In this case, for example, with the AC case to 0, we are going to check basically that we are going to send the message and we are not going to care about any acknowledgement, okay? So we receive an offset of -1, but our message has been received, hopefully. Okay, I mean, the UI is like cool, but it takes some time to refresh, okay? So we check that the message has been produced, okay? And the same with the consumer. Maybe after the presentation, if you have more doubts, we can go over that, but we have also a lot of things that can be configured, like the partition assignment, and with the policies that we have, polling intervals and heartbeats, and so on, okay? So we are going to move to the next part of the APIs, that are the process APIs.
Okay, cool. So now that we have seen like how to read and to put information in Kafka, we're gonna see that we are missing some parts, okay? we have the move APIs, which is the producer, the consumer, and connect, okay? But have you seen anything regarding state or stateful operations? No, so we are missing a local and fault tolerant state, a reset of operations, because what do we have at the moment? A method send and a method poll. That's it, not very rich, isn't it? And more advanced representation of streams. We have just topics, and that's it. You don't have an abstract over that in order to give more meaningful ideas over that. And of course, nothing regarding timing, okay? Time handling, nothing. They have options like other frameworks like Spark Streaming or Apache Flink that you can use, but for that, you actually need to set up a new server, you have to have people configure it, maintaining them, okay? And coming back to state. So stateless operations are kind of covered with the producer and the consumer, but what happened with the state? What happened when you have to do joining, windowing, or grouping, okay? You have to keep that state, and you have to keep that state between restarts, you have to scale that state, you have to replicate it, so things get complex when you get to the stateful world. So for that, we have Kafka Streams, okay? Kafka Streams belongs purely to the processing layer in the Kafka ecosystem, okay? And one of the nicest things of Kafka Streams is that it's a library, okay? It's not a server, it's just a library that you can plug in your current microservice architecture, and that's it, okay? It's not like you don't have to set up anything new, just a library, okay? So now what we're gonna be taking a look is how we're gonna start shaping our example, okay?
Yep, so for that, basically Kafka Streams leverages on a programming model called Dataflow programming, that it's data-centric and is basically, it wants to define our application based on some processors, okay? We have sources, sinks, and stream processors, okay? So in this example, we have, for example, orders and vouchers. We want to apply the vouchers to the orders that have vouchers, okay? So the first thing that we can do is we can filter. We can have a branch with the orders without and the orders with. We are going to then join the orders with vouchers with the vouchers, okay? And we are going to enrich this to another branch. And then we are going to merge, because in the end we want the whole information in the same place, okay? With vouchers applied or not, okay? So this is a very natural way of thinking about our applications, and when you see the code, it's really maintainable because it's like very structured, and we will apply also some functional style to defining the things, okay? So, as I mentioned, we have source processors that will put events into our system. We have stream processors that will apply some functional operators. Some will be stateless, some of them will be stateful, and we have our sink, okay? And in Kafka, there's this topology term that is basically the group of the different processors that we have, okay? That is the actually schema or definition that we have for our application. Kafka Streams goes one step further and divides source topologies into different sub-topologies in order to improve also the performance when consuming events, okay? So in this case, we have two, because we have one orders to the sink and one just for vouchers, okay? If we will have, for example, some filter in between vouchers and join, it will also take the filter in between, okay? How messages flow into the topologies? They follow the depth first approach, in which we will go, one message will go from the source to the sink, and we won't have more than one message at the same time in the same topology, okay? So this is really helpful because we know that we won't have any error because of sharing a state or anything between messages, okay? Because we will have just message processed at a time. But how this is materialized into the real world?
Okay, so basically now that we have the topology, which is like a template, and you can see where this actually gets executed, okay? The instance of a topology, it's a task, and it's something that we can configure in Kafka, okay? And actually those tasks are executed in threads by Kafka Streams, okay? The maximum parallelism that we can reach by reading those messages is actually determined by the number of tasks that we have configured, okay? The thing is that the number of tasks has a top, because in this case, for example, we have a topic which has 4 partitions. How much parallelism do you think we can reach on this configuration with the number of tasks? How many tasks do you think we have to top? 4. Because actually you have 4 partitions, and an instance, a task, at the end of the day, is just a consumer. And as Rafa showed before, a consumer, you can have the max number of partitions is the max number of consumers that you can have. The same happens with the tasks, because at the end of the day, they are consumers, okay? Now, for example, in this configuration, we have configured 2 threads, okay? But you see the number of partitions, you cannot do too much, okay? One interesting thing about the threads is that they are designed to be isolated from each other, okay? Now, let's jump into more interesting part, which is the high-level DSL and the processor API. So Kafka provides you with 2 kind of APIs. You have the low-level processor API, which is very interesting because you can access to low-level access to the data or the metadata. You can actually schedule periodic functions, and you have basically more granular access to state and to everything, okay? But this has some drawbacks because, you are in a very low level, so more verbose code, you have higher barrier for maintainers, and you might end up reinventing the wheel, okay? In order to avoid those things, we have the high-level DSL, okay? So let's talk about the operators on the high-level DSL. You have the stateless operators, in which you are treating events that they are just facts that happen, and they are independent from each other. You just process them, do whatever, and forget about them. You have here things like filtering, enriching, branching, or whatever. And the more interesting part, for me at least, is like the stateful part, which is like, if you want to analyze behaviors, you need to keep in the state what happened before. You cannot just forget about them. So you have to keep that information in some place. For that, you need a state, okay? And we have examples like joining, aggregating, and windowing, okay? Now, let's jump into the high-level DSL abstractions.
Okay, so everything is related to topics, okay? But we can see a topic in a very different way. We can see it as, for example, a stream that is like an unbounded flow of ephemeral events that we are going to process them one by one, and we are going to process them, execute whatever we want, and that's it. And we are not going to have any state, okay? Once we process an event, it's gone. Or we can view a topic as a table, okay? In which we are going to be consuming the different events, order 1, order 2, we are going to keep track of the status, okay? And if we have another, in this case, event with the same key, we are going to update it, okay? And we are going to keep track of the latest information that we have. And this is the information that we are going to keep track, okay? So we have streams and tables as abstractions for a topic. So how this is implemented in Kafka Streams, okay? We have different classes. The first one is ksstream that follows basically the record chain log semantics, basically, and is for inserts. We just process it, and that's it, okay? We have the, and it's partitioned, important, okay? We have the ktable that is also partitioned. It follows update semantics, as we have seen, and is partitioned at task level. So that means that for the whole data that we have, that in this case is a topic, we will have the data distributed in the different tasks, and that subset of the data. But if we want the task to have all the data, we have the global table in which each task is going to have the whole data that we have, okay? So the next question is, when do we use what, right? So we use ktable where in general we can't fit the whole data that we have in just one task because it's going to be quite big. Or if we rely on time-dependent features, okay? We can use a global ktable if, for example, our subset of the data is small and we can store it at task level, okay? So, talking about the state, as we need to store this in somewhere, we have the state stores, okay? That they reside at task level, okay? They are embedded at task level, and that's why it's like provides a better reliability and improved performance, okay? It's fault tolerant. All the state stores are backed into Kafka topics, so it's quite easy to restore the state if, for example, the task crashes or something. It's key-based, and we have 2 flavors, let's say, in-memory or persistent. We can have it in memory. We can have like all the information in RAM. That will be better performant. But in case of any error, we will take more to restore the state, okay? And we have the persistent. That is not quite only persistent. It's like a mix between in-memory and persistent. In this case, we are going to use RocksDB to store all the events, and in case that there is any failure, we can restore it quicker. Also on the fault tolerance side, I forgot to mention that we can also configure standby replicas. So instead of, for example, reprocessing the whole thing again, we can just configure standby replicas and then speed up the process of recovering a little bit more. Okay? So moving on to the example.
Okay, so let me start by having a look at the events that we're going to be publishing in the example that Rafa just showed. Okay, so we're going to be publishing events like this. So here you can see that we have an order with some kind of information like the product, the user ID, and the price. But you can see that some of them, they have like a voucher ID. Okay. On the other side, we have events as well, which are the vouchers that we have. We offer like 25% of discount, 50%, and 75%, okay? Those are the events that we're going to be dealing with, and they are already in the system, okay? Let's see now the topology. So, can you see it? Sí, eso lo voy a hacer. Ahora. Sí. Vaya roto, como no tiene, tío. Okay, so, let me just, all right, good. So, we're going to be building the topology that Rafa just mentioned before, okay? For that, what we first do is the stream builder, and we start by creating, for example, the stream of orders. We are using a stream. As we saw before, this is going to create a K-stream. Why? Because orders are events that, okay, they are just happen, and they are independent from each other, so we can use the stream. They come from the topic orders, of course. With this little magic from Scala, you will see that what we are doing here is creating the serializers and the serializers that I'm going to jump into them in a second, okay? Then we have the global cat table example. Why do we need, why are we using the global cat table for vouchers? Because the set is not big, and you can have a little copy on each of your tasks, and you have really quick access to them, okay? The same, a little bit of magic regarding the serializers and the serializers. There is no so much magic. What happened is that Scala is using implicits in order to import them, but they are defined here. You have a order serializer and order deserializer. They are put together under serdes, okay, which is something from Kafka Streams, and the same with vouchers, the serializer and the serializer for them, okay? And we import them here, and they are automatically get by as implicits, okay? So we have our K-strings for order, and we have our global cat table for the vouchers. Let's start defining the flow. So the first thing, if you remember, for what we have seen before, the first thing that we need to do is the split. Does this order contain a voucher or not? We do this with these predicates, which is basically, hey, do you have a voucher or you don't have it? So from the K-string orders, we do a split. We name the split with vouchers hyphen, and we do the branching. So if the order contains a voucher, we will have voucher present branch. If the voucher doesn't contain, is not contained, so we have voucher not present, okay? And we don't want to default to any branch. Either you go this way or either you go this way. You have voucher or not. Next thing that we do, and the more interesting part, okay? So for the ones that has a vouchers, we need to do the join with the global cat table vouchers. So we use the operation join, which is a stateful operation, so it will imply a state. And we do the next thing. So, hey, by which field do you want to do the join? By the voucher ID, as we have seen. And what do you want to do once I found a match? So what I want to do is applying the price reduction, in this case, okay? Once that we have the voucher present done, what we're going to be doing is merging again. So the ones that I apply the voucher with the ones that they didn't have, we merge them together, okay? And once we have the merge branch here, we say, hey, everything that you have joined already, they are orders again with the price reduction, and please, can you send them to the order voucher apply? For that, again, we have the producers. So we have the servers for them, and everything is okay. One important thing, as you can see here, what we have done is just the description of our program. Nothing regarding infrastructure or nothing like that. We just, in a very functional way, we have defined the description of our program. And this is one of the things that I like the most about Kafka Streams is that nothing regarding infrastructure so far. Now, let's jump into the application side, okay? Where we're gonna be actually running this. So the first thing that we do is grabbing the topology that we just created. We print it because later on we're gonna show you something really cool, and we put some configuration like the application ID or the address. With that information, with the topology and the configuration, we create the Kafka Stream application. We put some error handling over here. We start the Kafka Stream, okay? And if you stop the JVM, we're gonna close this guy, okay? Before running this, I would like to show you the testing part because it's insisting in the same concept, okay? So what we do here is, okay, give me the description of your program, not your whole program, the description, few properties, the topology test driver, which is a helper function that is gonna give us some cool stuff in order to do the test, okay? For example, it's gonna create an input topic, okay, that orders the vouchers and create the output topic. But actually, you can do few things here, like you can see, you can access the state storage, okay? In case you have stateful operations, we can actually access or join a state store in order to check things there, okay? So, and the tests are very simple, okay? The tests are like, hey, can you put in the vouchers pipeline this object? Can you put as well in the pipeline this object? And can you return the first element so I can check what is there, okay? We have one test for the ones that match the voucher and one test for the ones that they don't have, okay? Now, let's try to run the application and hopefully it's gonna work. So let's see. All right, so we should see here, okay, that those events are the ones that finish it, okay? Exactly, so basically, as you can see, oh, thank you, Rafa. So you can see that for the ones that has the prom 50, the price has been reduced from 300 to 150, and the one that has the 25, it went from 100 to 75, okay? So we have done the objective that we have, okay? Now, what I wanted to show is this amazing thing. So if you remember, we are printing here the topology, okay? And the topology is printed in a way that is not, let's say, very visual. So we have found over there, do you have open the?
Yep.
Okay.
Here.
This one. So we have this thing here, which actually puts you in a really nice way, okay? The topology that we just saw in the slides, it's here, okay? And it's what you are doing. So we have the orders topic, you have the streams, the voucher, the branching, everything, okay? And the vouchers is more simple because it's just that one, okay? But here you can see that it's very, very similar to the Dataflow programming that Rafa showed before, okay? So I think I'm not missing anything from here. Okay, yeah, but I want to insist of this because this is like a very thing that is from functional programming, which is basically your program is separated from your runtime, okay? You have your program has a description, that's nice, okay? And it's really good for testing, as you have seen. We haven't started a Kafka, and we are testing a Kafka Stream application, okay? But have you seen anything on the test regarding, hold on a second, regarding starting Kafka? No, that's it. You have the topology test driver that helps you with the creation of the topics, and that's it, okay? For me, that's one of the coolest things about Kafka Streams, that your program is separated from the runtime, okay? And now, let me jump again to the presentation. All right, for presenting the last part. All right, okay. So now that we have been talking about the Kafka Streams API, we're gonna be talking about the SQL APIs, okay? For that, we have another component in the Kafka ecosystem, which is ksqlDB, which is the streaming SQL database for Kafka, okay? As Kafka Connect is deployed in a separate server, okay? It has nothing to do with the main Kafka cluster. One of the more interesting things is that no coding is implied. So it has SQL statements. So the barrier for maintainers is very low, or for new joiners, it's like SQL, okay? And what it does basically is it simplifies the way your streaming applications are built, are deployed, and maintained. And what it does, as you will see, is like joining Kafka Connect with Kafka Streams, and it gives us a high-level SQL interface on top in order to use those components, okay? You will see that in a second in the example. But you wouldn't see nothing regarding Kafka Connect or Kafka Streams. You will see SQL statements, okay? So now, Rafa.
Okay. So we are going to move to the last example. Well, as you see, we don't like at all functional programming. So, okay. Okay. So I'm going to take a look at the screen because I have to do a few things. And yep. So just for you to know, we have everything with the Docker Compose. So this is like the whole suite. Okay, I didn't show it before, but well, just for you to check. And we have this ksql server. So the first thing that we have to do is connect to this SQL server because it's where we are going to actually execute the queries. Okay. So we go to this part. Okay. So. Okay, we are in. The first thing that we are going to do is configure the out of server set to the earliest, okay? Because this is a property for the consumers that if there is no information about the consumer group, and in the end, this is all like about consumers and producers, okay? It indicates from which point we are going to start consuming, okay? We can consume from the latest or from the earliest. So in this case, as we have already produced some events into the topic, we want to consume from the earliest message, okay? So we just configure it, okay? And now we are going to create a stream, okay? Based on a Kafka topic, orders, and the value format is JSON, okay? We have basically these two fields that we are going to basically have in real time a table in which we are going to count the number of same products that we have. So we create the stream. And in fact, we can see the events that we have for that stream with a very simple query. Okay, we select everything from order stream and we emit changes just to visualize them in the console. Okay, and we check this information is the same that we saw before. Is this information? Okay, with ID and product ID. Okay, so moving to the next part. Now we are going to create the table. Okay. Is the product counts. We are going to create with the Kafka topic product counts, the value is JSON, we specify one partition, and this is going to be the select statement. We want the product ID and the count, okay, from the orders stream, and we are going to group by product ID, and the same, we are going to emit the changes. So we create the table, oops. Okay, created successfully, and we visualize the data with the select statement. And as we can see here, we have this product ID, we have this that is updated with the second value, this one, and this is that the same that is before, that is this one, and is updated with the number 2. Okay, what happens if we, for example, execute the filling again? Okay, so we will see this is filling. That it's updated in real time. Okay, so that's a good thing about this real time. Okay,
nearly real time.
Okay, so that it's updated and we can see the information. We don't have to wait, you know, like to get to know about it. Is that we know at that time that we have this value, and we can store this and use it, you know, in our applications. So. Basically, that's it. We have here like other commands to show tables, streams, and everything. Okay. So coming back to the presentation, we are almost done. So conclusion. Okay. Well, I think that we have insisted a lot, but just in case, everything is really configurable. Okay. Like we can configure at topic. Partition, broker, cluster, producer, consumer, we can configure everything. And it will also depend a lot in our use case, okay? And we can have like a really good performance system or a really, really bad, just messing with 2 configurations, okay? It's also highly scalable, okay? Because we can scale the topics by having more partitions, and by having more partitions, we can have more consumer groups, and therefore we can have more computing power. We can add more brokers and so in the end, it's like it will allow us to to scale our system in a really easy way. It's true that we have to take care about, like defining a good number of partitions in the very beginning if we don't want to then end up, like doing some work just to allow that to happen, okay? But in the very end, it's also very reliable because with all the heartbeats and with all the broker management, like we are sure that the system is working fine. It also provides metrics that we can also publish directly to Datadog and visualize everything. And also in the Confluent platform UI, you see that the lag and everything related. But one of the most important things is that we have to change our mindset about how we view the data, okay? We are on a resting mindset, let's say, in which we have the data and we just take a snapshot of the data and we visualize it in that way, okay? So we have to change that mindset and go to a flow mindset in which we just see the data flowing and we react to that data. So that is what Kafka and Kafka Streams, it's a cat, so I think that is good. It's what is going to allow us, okay? Think about the data in a flowing state and be react instead of, like querying, when possible, these things, okay?
Okay, another thing that we would like to talk is about the great power, great responsibility, okay? So with the producer and the consumer APIs, you enable Kafka Streams, and with Kafka Streams, you enable ksqlDB, okay? But there is always trade-offs. So the lower you are, like at the level of the consumer and the producer, you have more flexibility. You can do a lot of things, but things get complex, okay? The higher you go, you're going to have better abstractions, so easy of use, but at the end of the day, you are losing kind of flexibility in order to do more customized stuff, okay? Last thing is like, we really like this technology, okay? And you can add it to your tool set, okay? But it doesn't mean that it's going to fit for everything. It has a lot of things that we haven't mentioned here, okay? But still, it's just a tool, like any other framework that you might have over there. So just keep that in mind that it's not for everything, okay? Now, we're going to jump into the reference. For this presentation, we have been taking a look at these books, okay? And they are really, really amazing. Overall, the first one is one of the best ones for me, at least, because it explains very well about Kafka Streams, about timing. It gets very in-depth, and it's, let's say, complex, okay? And yeah, I think that...
The good thing is that all of them are free, okay? So you can go to the Confluent, or I think that in Confluent you have the design event driven and the Kafka definitive guide, okay? It's quite outdated in some information, the Kafka definitive guide, like nice name, but it is what it is. But I think that the three complement each one like really good. So you will have like plenty of information just to read before sleeping, and it will be amazing. Okay, so that's it. If you have any question, now is your time to sign. Okay, come on.
My question is regarding the consumers. So you mentioned they maintain states of the offset and everything, and you were not clear for me where is that state stored?
Basically, they were saying that basically where consumers keep the state in which they are consuming from the topic, okay? And
you can show in that.
We are going to check. They basically publish messages into the one special topic that is called consumer offsets, okay? In this one, we can't see it, okay, but all these messages are being produced by the consumers, and these, have the information about where to go in case that something happens, so here. Do we have any question from streaming? No?
It will come up
okay.
Tomorrow?
Okay. but today the answer is free.
Yeah. For the
Okay, so maybe like tomorrow.
More questions, guys?
I have another.
Yes.
The Kafka Streams, you said that they are stateful, right? So what happens if some application breaks or you need to redeploy? How do they, can they use that state? Or?
You're talking about the state. So basically the question is regarding like how do we keep the state between restarts or how we scale it and things like this. So basically, what it does is we can select, Rafa has talked about that, but okay. So basically, you can say, hey, I want my state not to be only in local, but I want to replicate it into Kafka. So you have a topic in Kafka with the states of your local state or your local store. So when you restart it or when something crashes, what you need to do is recreate the state thanks to a topic that you have in Kafka, which is replicating that state.
Regarding that state also, what happens in the case, for example, you have a duplicate voucher event, it would apply twice the discount to the order, or how that works?
No, because it has the same key. So as Rafa mentioned, it's going to be absert. You're going to update the table. The global cat table that we show, so basically, it's going to be abserted. More questions, guys, please?
I have another one.
You have to pay for this one now.
It's making the most out of it.
The basics of Kafka, can you guarantee the ordering for all the events in a topic?
Yes, if you have one partition,
Yes.
so you can have it. Okay, but again, that's a really good question, because in fact it's not only by having just one topic with one partition, because in the end all the messages will go there, right? But it also depends on how you configure the producers. Okay, and I think that it's a nice subject also to talk about delivery semantics, that maybe we didn't cover it quite in deep, but this is like an introduction. But in Kafka, you will see that they have exactly once delivery semantics, and that's sometimes related to only the producer side, okay? Because you can produce exactly one message, but then another different part is when you are consuming, okay? Because in the end, it's okay to just produce exactly one message, but what happens if you, for example, your consumer crashes and you consume again the same message twice, and you don't have exactly once end-to-end semantics, okay? But then also, well, maybe this is like for another talk.
Yeah, and we have transactions as well.
Yeah, we have.
And we are not even mentioning in the presentation, but you have actually transactions in Kafka, which is like more things, you know, on top of that. So
the good thing about Kafka Streams is that out of the box provides exactly once for the whole flow, like producing for example, from end to end, like you read from topics and you produce to another topic. If you perform operations in between, no, because it's up to you, okay? But it's quite well supported. Also, performance is really impacted, okay? But in the end, it's quite good, and it works really good. I mean, we have tested it in production, so.
yeah.
Okay.
Can you have different objects for the source and the sink of a single stream?
What do you mean?
So read orders and generate another view?
Read orders.
Could you explain?
Yeah, in the stream you were using, you modified a single order. Can
Yes.
you,
Like this one, you mean, right?
yes. Can you have a different object in the sink?
Yes.
Exactly.
Yeah.
We are just, in fact, well,
I think we are using the same.
in this
but,
case, they are the same, okay? But if we just change it, it's no matter, we have a new guest.
yeah, actually, this object here is basically, okay, it's the same because we are copying it,
Yeah.
but as long as you provide a serializer, you can produce in the output whatever you want.
Yeah. And also, again, we didn't cover, for example, the schema registry and how you know that. But for example, right now, also in the schema registry, we can configure also protobuf apart from Abro, and you know, like we can have events only in JSON or in Abro and protobuf, and the idea is to have it centralized and provide backwards compatibility between the events and everything. So.
From the consumer point of view, is there any way of filtering messages when you're like reading from a topic? Like let's say you are only interested on updates or the creation of
Well, you will have to do it at the consumer API level. You will have to do it in your application. There is no way to subscribe and filter like function, let's say, right? So, but for that, yeah, like it's the thing is that it's a good way to combine both APIs, like producer and consumer. So, because maybe by producing from your application or from your system to different topics, then you can build Kafka Streams application that will do that for you, you know? And maybe at the end of the Kafka stream, just have another consumer API just for some business logic, okay?
Yeah.
So
The fact that they provide a filter method means that, yeah, you want to filter, but once you have consumed the event, once you have polled it.
What happens once I consume an event, so, and the producer produces the same event? With the same key, I guess. I see it. There is some meshing.
once, sorry?
I consume the topic,
Uh-huh.
for example, and I receive the key 1.
Okay.
The producer produces again the same.
Yeah, but the same event or an event with the same key?
If it's with, yeah, if it's the same key, actually you're gonna be consuming it because the compaction.
Yes, sorry, because I messed up. I forgot to repeat the questions.
Oh, the
okay?
questions.
Next time we will have a microphone just for you to play. So basically, he asked about what happens if we consume an event with some key, and then the producer produce an event with the same key but the same value, or like the same event, or just the same key. We can ask both if you want.
Yeah.
Okay, okay.
I meant exactly the same event, but if you want to answer both.
Yeah, no, because the answer will be the same. So.
Yeah, exactly. So, no. If the event with the same key is sent, even if at the same, exactly more or less very close in time, that if you have the topic compacted, okay, in that case, if the compaction logic doesn't happen, you're going to be consuming both events with the same key. The compaction logic is not something that happens immediately. It's something that runs in the background and it continues to go.
That's why we're asking. So if you probably have duplicated events, you have to deal with that in the consumer side.
Yeah, exactly. And in fact, that's a good question because talking about compaction doesn't work like in real time. So how Kafka works like really deep level is like it works in like log files, you know, like segments, let's say. So only segments, like full segments are the ones that are going to be compacted. So it could happen that you are working in a compacted topic, but you can read events with the same key, even though it's compacted, because it's only like a subset of the topic, the one that is going to be compacted. So.
You actually have an active segment. The active segment is the one that is receiving information, and then you have the other segments. On the other segments is where the compaction logic happens, because they are not active. But on the active one, they are receiving message. If you are sending 3 events with the same key, it goes to that segment which is active, and you're going to be consuming them. So. More questions, please?
Any question from the outer world?
Okay.
Well, thank you.
Thank you. Beer time?
Before that,
we have some things.
okay, but are you going to raffle something?
Are you going to raffle something?
I am going to raffle something.
Oh, wait.
Okay, so, but, ¿me dejáis un
Sí, dale.
how many things are we raffling?
From our side, we are raffling 10 promo codes for Globo for 10 euros. Okay, so.
Well, that's a lot of things.
Yeah. But just one for each one, so you can't win all of them, you know. So.
Okay, and on our side, as you know, JetBrains is one of the sponsors that we have at the Java User Group, and we are going to give away 2 JetBrains licenses. It could be for any JetBrains product. So it could, if you already have IntelliJ, you can book another one. So, but this is the way we are going to do that in order to make it easier is we are going to raffle the things only between the people that are here present. Not, sorry guys, the people attending online, next time come here and you will have more chances to win something. So before doing that, so first thing, we are going to close the connections with our outer world friends. And then after that, we are going to raffle the lot of things that we have here. And so before closing the connections, just a reminder, we are restarting our meetups in person again. We have already scheduled, not published, but already scheduled another meetup for June 23rd or 24th. I don't
23rd,
remember.
I hope.
23rd. So probably we are talking probably to have another one maybe at the beginning of June, but that's not confirmed yet. But the point here is that any one of you can step in and share with the rest of us what you are doing. I always say that sometimes we think that we don't have anything interesting to share with the rest of the world just because we have been working in something for the last, I don't know, months, a year, or maybe a couple of years. And so we don't think that we are doing any interesting thing, but the point is, it is interesting for the rest of the world because it's probably not something that they are doing and they could benefit for what we are doing. So don't be afraid, just step in and reach out to any one of us and just tell us what you are working at, and maybe there's something very interesting that you are doing right now that could be interesting to share with the rest of the world. So don't be afraid. If you don't have any previous experience giving a talk, don't be afraid, just tell us and we can help you to deliver the talk or to even prepare the talk. So don't be afraid, and any one of you can step in and can deliver a talk or just help organizing the Java user group. This is something that is not from us, it's for everyone. And another important thing is, if you don't have a talk, but you are interested in a topic, just also say it so. Say, hey, I would be interested in anyone speaking about, I don't know, more in depth about Kafka, or about a little bit of functional programming in Java, or I would be interested in something like that. Or maybe it could be interesting to have some kind of workshop on initial topics or in concurrency in whatever you are interested. Because maybe there's someone out there that is doing something with that specific topic that you are interested in, and it's kind of shy and reluctant to step in and share what they are doing. So if you have something to share with the rest of the world, say it. If you are interested in anyone speaking about something, say it. If you are interested in proposing a different kind of activity, say it. Just say it, please. And I think that's going to be all for today. I would love to close the connection by asking for a big round of applause again for our speakers today.